Thank you, everyone. So this is the last talk before Carlos replies. I'm happy to present Mauro Dorato and Matteo Morganti, both from University Roma 3. As I was saying, talks are usually 30 minutes. If you need a bit more time, it's okay. Do you want me to warn you both?
Yes, please.
Only one.
Well, just do it with Matteo. But no, please do it with me and with him, because we have 30 minutes, right?
15 each, if you...
Okay, 15 each. So just wave your hands when I'm close to 10 on 12. Okay, I'll be brief anyway. So first of all, thanks to the organizer for having put together such a great group of people. And it's actually very pleasing for me to talk about relational quantum mechanics. And as you see, the title is What Ontology for Relational Quantum Mechanics. And the kind of methodical strategy that we'll adopt here is that supposing that relational quantum mechanics is approximately true, or whatever that means, that is a good description of the quantum world is nicely described by the theory. We're trying to ask what are the readings of RQM vis-a-vis current attempts to uncover the fundamental structure of reality. This is really a very big word. But we're going to analyze quickly the three main positions that are actually being discussed, namely priority monism by Schaffer and Israel, ontic structural realism, which has been developed by Candiotto, and finally, the last part is going to be explained and talked about by Matteo. This part is basically labeled in the literature as quantum coherentism, and Matteo and Claudia are, basically the people that really propose. And I'm going to touch briefly, but really briefly, the problem of time in priority monism. There are two distinctions distinction that needs to be made between existing monism and priority monism. The existence monism is really a very implausible and metaphysical view that goes back to Spinoza or Hegel. The idea is that the parts of the universe are just a part, but only the whole exists, or if you want, it exists in a real fundamental sense. I think a more plausible view, it's priority monism. The idea is that the whole is explanatorily prior to the parts. And as you will see, what is written in yellow is really one of the weak points of priority monism. What does it mean? The first question that I'm going to ask is, what does it mean to be explanatorily prior in the context of relational quantum mechanics? Our problem was, we need to translate this language into physical language. So we guess that the whole is the universe, or at least the observable universe. The explanatory dependent parts are various physical systems. And if we are referring to the universe, we can talk about, say, the map of the Wilkinson anisotrope probe. This is the wonderful map. So we have a part, which is the probe, and the part interacts with the cosmic background radiation, which is the other part. So one part gains information from the other part. I'd like to say something about the philosophical background on relational quantum mechanics, which I think goes back to Leibniz. And I read a beautiful paper by Julian Barber about the fact that according to relational quantum mechanics, the parts of the world are really moments that represent the universe, Schaffer's and Ismail's whole, from a particular perspective, which is basically, in physical language, one of its parts. And here I'm quoting a collaborator of Carlo, Lee Smalling. The impossibility of self-descriptions is basically corresponding to the fact that there are no monads of the monads. And the quote is, each observer can only have incomplete information about the universe, so that the most complete description possible of the universe is given by the whole collection of incomplete but mutually compatible quantum state descriptions of all possible observers. Now, just briefly about relational quantum mechanics. There was a quotation from Carlo here. Do observers O and P get the same answer from a system S? Well, this is a meaningless question. It's really a question about the absolute state of the observer, which is not, as we have said several times, it's not a conscious observer, but it's any system whatsoever and the part. Well, if you consider that S in this case is the universe or the whole, in a very literal sense, we should say that it's meaningless to refer to its absolute state independently of its parts. And this is obviously a direct contradiction with respect to priority monism, because the universe cannot be explanatory prior to the parts, because it is in no absolute state. And there is no interaction independent description of the whole. So in this very first step that I'm trying to take against the compatibility of priority monism and relational quantum mechanics, I think that it's a significant objection. If there are no absolute states, then consequently there are no even definite states of the universe, except, and maybe here we should add Richard's suggestion, except by referring to a particular part within the universe. So the second problem, there is a symmetry between information exchange and asymmetry between explanatory relations. So unlike priority monism, in relational quantum mechanics, the universe can only be described from within, namely from the parts P, I, P, N. But in physical terms, descriptions really refer in Carl's language to exchange of information. Or, if you want, a nomic correlation between two systems interacting. And such interactions, of course, are governed by the bond rules. Now the question is, second objection, you, the universe, cannot be explanatorily prior, whatever that means, to its parts, because in relational quantum mechanics, the correlation between you and any of its parts is symmetric. But obviously, I guess the relation of explanation is asymmetric. So there is, I think, an obvious conflict here between relational quantum mechanics and now there is the problem of time, but obviously only applied to priority monisms, various views. There is a dilemma here. Either priority monism, the universe that the priority monists describe, evolves in time, or it does not. But now suppose that it does, which is implausible consider this holistic view, then it seems to me that priority monism presupposes a privileged cosmic time, or some sort of very speculative shape dynamics theory. But relational quantum mechanics requires relationism in terms of relations between physical systems, exchanging information to gather a certain temporal information. Well, then the most plausible reading here is that according to priority monism, the most plausible interpretation of the universe is the so-called block view, where basically the ontological distinction between past, present, and future is absent. And the block view, I would say, is at least partially incompatible with an ontology of processes and events. Because, as Weil used to say, in relativity, events do not happen, they just are. this is, of course, opening a Pandora box. But again, if there is, this is the teaching of relativity, there is no universe at the time t. If there is time, in an objective sense, it's time that is somehow measured along single word lines. So this sort of objective time is hardly reconcilable with priority monism, which needs the idea that there is a universe, it seems to me, at a certain time. And you cannot talk about a universe at a certain time because there are very many ways to slice up this universe, this block. And another problem that cosmic time, it seems to me, raises for priority monism is the fact that priority monism requires, excuse me, very restricted model-dependent privileged solutions of Einstein field equations. And one last problem that I see here, that according to priority monism, this cosmic clock must be explanatorily prior with respect to local clocks, which belong to the parts. But in relational quantum mechanics, it seems to me there is no external cosmic clock. So we measure time by comparing local clocks, namely local physical systems, with changes in nearby regions. So just to summarize my part, it seems to me that relational quantum mechanics is more liberal than priority monism, and I see this an advantage because in this sense, relational quantum mechanics presupposes less from the physical structure of the universe as far as we know it, while the requirements of priority monism are much stricter. So they seem somehow ad hoc. They're trying to adopt basically the physical description of the world to their own pet metaphysics. So they need the idea that there are no closed time-lock curves, so that the universe in physical jargon is causally stable. They have to deny that there is some sort of coming into being even at a local, in a local sense, which I think is very reasonable in the sense that one event is then followed by another event, but before the later event does not exist in any sort of sense, not even in an unrestricted sense. It needs time symmetric laws because the whole basically determines any of its part, but this determination plausibly is time symmetric. And most fundamental laws of the universe are time symmetric. And finally, I'm not going to develop this. I'm not able to explain what this explanatory priority really amounts to, because the only notion that I know of is physics, it's explanation in physics, and you have very, very many options there. But they never try to relate this metaphysical notion of explanatory priority with physical explanation and whatever counts for explanation in physics, say nomological explanation. I think I should leave the ball to Matteo at this point. Do you want me to advance the slide, Matteo?
I can try to share mine.
Okay, great.
Mauro, I think you have to stop.
Okay. I'm sorry.
Can you see it?
We see Gazzetta.
That's not the point. Wait.
I see a blue car.
Congratulations.
Now you can see many things. Let me try again.
No, I think Mauro has to stop sharing first.
I'm ready to show mine.
No, leave it. Leave.
Okay.
No, it just doesn't work now.
Okay, now you can share, Matteo.
Let me try again.
All right.
Can you see it now?
Perfect.
Okay. So I'll try to be as good with time as Mauro did. So as Mauro mentioned, the second option we want to discuss today is this interpretation of relational quantum mechanics in terms of structures. And a recently very popular claim is that really we should make sense of relational quantum mechanics in terms of ontic structural realism, which is a thesis, very popular thesis in philosophy of science nowadays. Actually, ontic structural realism is the conjunction of two very different theses, and we only care about the second thesis here. So the first one is a sort of epistemological thesis, trying to find a sort of formal structural continuity across the history of science so that we can be realist about science in spite of all the revolutionary changes that we are all familiar with. But we don't care about this. The important component is not the realist component, it's the structuralist component. So the second thesis is the ontological thesis according to which reality is at root relational. It is important, very important to understand what structuralists mean by this. And the idea is basically that physical relations are more fundamental than objects. In some cases, moderate structuralists, they claim that relations and objects are equally fundamental, but we will ignore this. The most popular view is that really what physics teaches us is that relations, not objects, not relata, not monadic properties, even though relational properties are fundamental. Now there is a bunch of arguments which are very often run together from quantum mechanics to structuralism. You can find many claims in, for example, Stephen French's articles. They talk about symmetries, the role of invariance, group theory, quantum statistics, quantum non-individuality, and what have you. Everything is understood in terms of relations. In the case of relational quantum mechanics, the idea is in a way simpler. The idea is basically that given that it makes no sense to talk about individual physical systems and their monadic properties in relational quantum mechanics, and given that properties are essentially relative to other physical systems, then physical relations must be prior at the fundamental metaphysical level. This argument can be found in more or less this formulation in Candiotto's paper, which Mauro already mentioned. In the paper, she says exactly this. Since interactions, she says between systems and instruments, which is potentially misleading, I think, but forget about it. Since interactions play a crucial role in relational quantum mechanics, then it is natural to interpret it in terms of relations, objects turning out to be mere nodes in relational structure. So this second of the claim is very important. Objects are really derivative on relations. And the claim is that relational quantum mechanics makes this sort of claim. Now we think that intuitively it makes sense to try to translate talk of interactions between systems into talk about relations, but actually we think that upon scrutiny, this doesn't really hold water. And we try to express our worries in a list of 4 objections in increasing order of significance. So the first objection is very general, and it doesn't have to do with relational quantum mechanics. It's not even quantum mechanics. It's a general objection to ontic structural realism. It seems to us that the notion of structure or the notion of relational structure is notoriously ambiguous, and it remains ambiguous in the philosophy of science literature. In some cases, it means formal continuity across theories in physics. In other cases, it's about the role of group theory and invariances in some theories. It's really hard to pinpoint one particular meaning of relations. And of course, the worry is that if we don't know what a structure is, then being fundamentalists, whatever it means about relations at the metaphysical level, is not really clear what it means. But forget about it. Suppose we have a working notion of structure. The second objection, it seems to us, is the following. The structuralists typically say that every property, every physical fact can be translated into a claim which is fundamentally about relations, including state-independent properties, allegedly essential properties of things which determine the kinds of things, for example, the kind of particles we are interacting with. And it seems to us that relational quantum mechanics doesn't do that, or at least it doesn't have to do that. State-independent properties are simply not relative to other systems. They might be, but it is not needed to make the explanatory work that the theory actually wants to do. And this is a big difference, because you cannot be a structuralist if you claim that state-independent properties are traditional monadic properties. Of course, we can discuss it later. Many structuralists insist that we have to translate state-independent properties in relational terms, but it seems to us that they fail to actually prove this so far. But again, assume that this objection can be responded to. Now, the key point emerges. As you remember from the quotation, the idea is that since interactions are crucial in relational quantum mechanics, we need to take relations to be metaphysically fundamental. Of course, there is a connection between two things interacting and two things being related. But our worry here is that really Carlo doesn't mean what the structuralists want him to say by interaction. An interaction presupposes two interacting things, it seems to me. While for the structuralist, relations being fundamental means, as we saw, that objects are really derivative of relations. So we don't have anything to begin with. We start off with relations, and then after that, obviously it's not a temporal after, it's a metaphysical derivative nature of objects. Objects come later. So the question here is, can we really reify interaction? So of course, an interaction is an actual physical event. It is physically real. But the claim that the structuralists are making here is stronger. The claim is that relations are literally the basic building blocks of reality. Of course, this claim can be defended, but we believe that this is not what Carlo wants to say. And it's a stronger claim than what it needs. And this leads me to the fourth objection, which is immediately tightly connected to the previous one. The point here is simply to draw your attention to this difference. There is a difference, which is a deep philosophical difference between something being fundamentally relational or extrinsic on the one hand, and something being fundamental as a relation on the other hand. Now, what we claim is that Carlo really wants to stress the first thing. We have sort of more or less traditional physical systems. We can maybe use the word object, and these objects are essentially relational. Their properties are essentially extrinsic. But be careful here. What is key is the talk of objects with extrinsic properties. So at no point do we need a talk of relations being fundamental. Let me just give you an example. What the structuralists typically use as an example of a physical relation is something like this: the relation of having opposite spin in the x direction too. So the structuralist claim is literally that reality is fundamentally constituted by these sort of things, having opposite spin relations. While it seems to us that what relational quantum mechanics says is something completely, well, slightly different. The typical relational quantum mechanical claim is that system S is, say, spin up in the x direction with respect to system O. So Carlo seems to presuppose S and O as two relata. And this is sufficient for not being a structuralist, because we are not reducing relata to relations. Okay, so if you agree with us so far, it looks like it is at least possible to understand relational quantum mechanics in terms of more or less traditional metaphysical categories. It might be objects, it might be bundle theory of properties, as Andrea, for example, recently suggested, if I understand him correctly. But we do feel that there is something more to explain. It is desirable, at least, to say something more about this particular label. Why is the theory relational? It is more or less clear from what we said so far, but we still feel like we need to say something from the point of view of metaphysics and ontology to make sense of this. In other words, we cannot just make do with traditional bundle theories of properties. Which properties do we have? How do they work? So to end the talk, we will briefly mention these third proposal, which is, of course, a shameless plug. Forgive me for the self-advertisement, but it is recent work that I've been doing with Claudio in the last couple of years. So I will just offer it to you as an option. The proposal is this: relational quantum mechanics can, at least, maybe it should be interpreted in terms of metaphysical coherentism. So what it is, I will give you very quick, rough crash course. The basic idea of metaphysical coherentism is that it is possible, and perhaps it is actually the case, that relations of mutual ontological dependence hold between different physical systems at the same level of complexity. The counterpart is usually obviously the traditional foundationalist view of reality, according to which reality is really a sort of hierarchy of levels in which facts at one level can only be explained in terms of more fundamental facts. Now, metaphysical coherentists reject this idea. It could be that physical systems at the same level of complexity, they are symmetrically dependent because the existence of one affects the features of the other one. Symmetric dependence is key here. Another thing that metaphysical coherentism departs from is the Hume-Lewis sort of ontology based on Humean supervenience and this idea of a mosaic of local quantities, which we really think is untenable, but many people defend it nowadays. And it seems clear to us that relational quantum mechanics is really incompatible with Humean supervenience and the like. But what does the metaphysical coherentist actually say about physical system? Let me start with a simple example. Quantum entanglement. This is really a toy example, basically. The idea of the metaphysical coherentist is basically that entanglement can be understood in terms of contingent mutual relations of symmetric dependence between physical systems. And this symmetric dependence affects the properties of the system. So consider, for example, the singlet state. The coherentist story here is that you have two independent systems, 1 and 2. Upon interactions, they become connected in a way which is not, strictly speaking, causal. It's something stronger. It is a sort of modal connection, which is directly mirrored in the quantum states. So what we get is an entangled system with total spin 0. Of course, you know that. And what we get in turn is that given this and the laws of physics, the interaction sets constraints on the possible properties of 1 and 2. So because of their mutual interaction and their mutual dependence, which arises as a consequence of interaction, then 1 and 2 can now only have some of the spin values that were possible before interaction. So we have a sort of modal restriction on the possibilities, the physical possibilities that are open to physical systems 1 and 2. And this is what we mean by symmetric dependence. It's not really causal dependence, it's something more. It's the way in which the modal structure of things actually is, as mirrored by the relevant physics. Now, the key thing to notice here is that it is natural here to talk about individual systems 1 and 2 and their monadic properties. So it's not about relations. It's about monadic properties that literally belong to system 1, system 2, or whatever. What is essential is that these properties are not intrinsic. It doesn't make sense to attribute these properties to 1 or 2 independently of the environment. In other words, the existence of 1 is essential for determining the possible properties of 2 and symmetrically the other way around. So as I said, this is not really relevant for relational quantum mechanics. It's a much more general coherentist claim, but it's easy to generalize, of course. Now, the claim that the coherentist would make about relational quantum mechanics is that quantum systems are really essentially dependent on other systems for their, let's call it, qualitative profile, in particular for their state-dependent properties. What does it mean? Again, it means that the systems have monadic properties whose values cannot be identified in any absolute sense, but only in a relative sense. Again, at least for state-dependent properties. And the relevant dependence relations are not any sort of mysterious metaphysical addition. They are just what we find in the theory, in the quantum states. So what we know about the states is facts about their mutual metaphysical model connections. Two crucial points. It should be clear by now, but let me be even clearer. Coherent.
A couple of minutes more.
Yeah, I'm done. Very briefly, it should be clear by now, but it is important to see that coherentism is not a form of monism, because unlike monism, we don't need to posit a whole which is more fundamental than the parts. We are positing symmetric connections between the actual things that exist, actual physical systems that we can find in the labs or whatever. And again, it's not a form of structuralism because we are not using relations. Relations don't really play any crucial role here. Interactions do, but difference between interactions and relations can be mirrored by focusing on the relational features of monadic properties. So obviously this is a key point. We will probably have to talk about this difference between relations and monadic relational properties. In metaphysics, this is a fundamental distinction. Let me just add, I will not go into the details here. Of course, there is more to say about properties. What does it mean that properties are modally connected? Our idea is that the most natural way of making sense of this is by adding to this coherentist picture a sort of dispositionalist view of properties of the sort that Mauro has been working on for a number of years now. And I will only read the second box, dispositions with variable manifestations, in physical interactions being the condition for the manifestation of these dispositions. And we think adding this to coherentism makes sense of all the key features of relational quantum mechanics. But again, we can discuss it later. Let me just close by summarizing very briefly what we did. Mauro started off by pointing out the basic features of relational quantum mechanics and the need for a clear, understandable ontological interpretation of the theory. We briefly discussed the monist and the structuralist alternative, and we found them wanting. And we ended up suggesting the possibility of a new, novel, relatively novel understanding of relational quantum mechanics in terms of metaphysical coherentism on the one hand, and a dispositional understanding of properties on the other hand. Yeah, that is all. Thank you very much.
Thank you, Matteo and Mauro, both. Okay, so we have around 13 minutes for questions so that we can take a small break. Baptiste, you're first.
Hi, thank you very much. It was a lovely presentation, really learned a lot. I mean, I have no strong opinion about which is the best between the three views, but I was thinking during the first part of the talk that I think there are reasons perhaps to defend the priority monist approach, or at least I was not convinced by the two arguments that were given, right? So the first were, I mean, so you think of the world like a collection of monads, right, corresponding to all the building blocks. And then the question is the cosmos more fundamental than all these things, right? Does it go from the bottom upward or the other way around? And I mean, I get it that we can really explain, I mean, the order of explanation seemed to go from the interactions at the bottom to the cosmos. But if we are a bit more flexible about the linkage between explanation and fundamentality or priority, perhaps there is room to say that the cosmos is still more fundamental than the parts. And then for the second argument, it was based basically on a dichotomy between having either static time or dynamic time. I mean, there, I guess we should also discuss the possibility that space-time itself is not fundamental, right? So there should be a third option to be discussed. And I mean, I think we can have a kind of block universe view in which the building blocks are some kind of dynamical building blocks. I mean, some people like Nathan Oglander in the philosophy of time have some kinds of view where relations are building up the world, but relations are intrinsically dynamical. So there should be also some room there to have a kind of priority monist view. I mean, just a bunch of thoughts. I haven't been thinking about that, but would be happy to know what you think about this.
Thanks, Baptiste, for the questions. The problem with, I think, with this monism point of view, they never clarify what this whole is. If the whole is the universe laid out in a four-dimensional space-time, which I think they're being referring to, then the problem seems to be that there is no God's eye point of view. So that it's difficult to describe the universe if not from within. If Carlos' view is correct, of course. I was with Matteo presupposing that Carlos' view was the view that should be, at least for the sake of the seminar, and also for the other reasons that we may have, to see whether that view, the Carlos' view, was somehow strong enough to rule out priority monism. And if we agree that there is no God's eye point of view description of the universe, because we are within the universe, and we cannot but describe the universe as being a part of it, then it seems to me that this priority monism view fails. Can you please remind me of your second question, briefly? I remember the third. The third was about the block view, right?
I mean, I'm not sure about my way of spreading the question. But I guess maybe.
Sorry, go ahead.
I mean, just on that, I guess my trouble is to understand why the fact that we cannot describe the whole of reality, right? Well, I mean, it could be that the whole of reality is not. It's not possible to describe it as a whole. But why does this claim entail that the whole cannot be more fundamental, right? I mean, is it really some kind of analytic implication? I mean, it seems to me that there is something more to say to I mean, yeah, I don't know.
No. I see your question, and it's a very good one. If the whole is explanatory prior, it means that the whole somehow should be explaining any part of the universe. But there is no possibility to describe a part of the universe in the sense that the part cannot give a self-description. So that it's difficult to understand what they mean when they claim that the whole is prior to the parts. And
if I may add something to this, just to make it clear, as I understanding, our claim is not a logical impossibility claim. It's a matter of how powerful a philosophical explanation is. And it seems to us that basically the point is it really natural? Is it the best explanation for a physical theory that is entirely in terms of correlations between these systems? The claim that there is something which is fundamental in spite of the fact that it's not correlated to anything. It really looks like a step that is not required. And if possibly, it makes things worse in terms of explaining or understanding. So it's definitely not a logical impossibility claim.
As to the third question, yes, I know Nathan's view, but it seems to me that you take seriously the block view. You don't have any coming into being, and the coming into being is essential to the fact that you give an explanation of what we experience in our, say, basically in our consciousness, that we anticipate the future. But if everything is there, so to speak, and that's what the priority monists require, then you cannot really have somehow the possibility of explaining our experience. So you have to adopt the block view, which is incompatible, it seems to me, with any dynamics coming into being, because somehow every event exists on a par. While in relational quantum mechanics, you can actually defend a local sort of becoming along world lines. So you have proper time, and proper time is obviously objective, but you cannot extend proper time throughout the cosmos. And this is, I think, what priority monists require or should require. I don't know if I actually replied. to your question.
Right. I mean, I don't think I agree, but I better understand your point of view. I mean, I still think we can have some kind of local becoming consistent with a block universe view or something in the spirit of a block universe view, but I don't want to take too much time. So thanks a lot.
Yeah, thanks for your question, Baptiste.
Thank you. And Hanok, you're up next.
Thanks very much. Thanks very much, Mauro and Matteo. I have a question, I guess, to both of you, but even beyond that, to Carlo and others. You mentioned the state-independent properties. And so I was thinking, to what exactly does relational quantum mechanics commit itself when it talks about the place of relations? Let's say I take 10 protons, 5 electrons, throw them into space. Their mass, their charge, if they have other such properties, these are not relational. These are the relational properties are the relative location, relative momentum. We all know these are relative properties anyway. We don't need the quantum mechanics for that. So are there any, so is anybody going to deny that the number of protons, the number of electrons in space, the rest mass, the charge is non-relational? And are there any new kinds of properties, unlike momentum, spin, and so on, which become relational and which are not intuitively relational? Because if not, then there's not such a kind of metaphysical outrage in the relational position. So that's my question.
I want to take it, Matteo, and then I can.
Yeah, okay. I think we are on the same page here. Our basic claim is that you don't have to be a structuralist given what we know about quantum mechanics. And actually, if you want to do that, you need to engage in all this sort of translation work. I have all these easy properties. I look at them, they are intrinsic and monadic. And to be a structuralist, I need to make a mess trying to show that they are structures after all. And I've been reading the literature with care, and I think they are successful in convincing. Apart from the fact that I don't like structuralism, I didn't find convincing arguments for reducing intrinsic properties to relations. If anything, what is happening in the literature is that structuralists are starting to realize this, and they're starting to make more modest claims about almost all properties.
So I add something to this fact that you described now. Are there any relational properties in relational quantum mechanics which we wouldn't intuitively take to be relational? Is there any problem there? Because momentum, spin, these are relational. No news here. The interpretation of the theory is the news, but not the fact that these properties are relational. Is there any property which you would like to say, no, that can't be relational? And RQM tells you, yes, that's relational.
I don't think so, but obviously Carlo knows better. So, I don't know about number. You mentioned number of particles. That's a slightly different issue. It's an interesting question. Carlo, sorry.
I have to reply. Maybe I'll take your question and I'll add to my replies after. I'll try to say something. I don't disagree with you mostly, but I would dot some I's.
Okay, thanks very much.
Mauro, I don't know if you want to add something on this.
Well, neither do I disagree. I think Matteo was just drawing a distinction between, say, mass and charge on the one hand, and properties like spin on the other. And the idea is how to make sense of correlations like spin correlations without bringing in priority monism or structuralism or bundle theories of relations. So the idea was trying to eliminate one by one this most discussed view and focusing not just on mass and charge, but basically on correlational view. So that, I mean, of course you can treat systems independently of one another. But the idea is that I think Carlo should say that before the interaction, that's what he should say. I mean, in the case of having a mass, the interaction just basically gives you the particular value that the system with that mass has. But having a mass, I think, is previously possessed by the object. While in many cases, well, of course, in many cases, what you measure is not what is there before. This is what I should say, or what I have to say. But
I don't want to take more time, so if we come to this later in the discussion, I'll come back to that. There are other questions.
I'm sure we will with Carlo. So, well, Claudio, if you want to ask the very last question.
Yeah, sure, why not? So first of all, two things, one with the Mauro part and one with Matteo's. So I think that there might be actually in the Mauro's part, I agree with all of you said, guys, but I think there might be even a more basic tension with priority monism and Carlo's view. As a matter of fact, I don't think that, for example, Carlo's view is even committed to the existence of the universe, like in the technical sense of the mereological fusion of all the quantum systems out there. And this is extremely important in Schaffer's view, in priority monism. And it can even, so it has two moves, either deny that there is a universe, like the mereological fusion, and say, when we say universe, right, it's just a terms that refer plurally in the semantics, or second, say, even if there is, I cannot attribute any property to it.
exactly.
Because
Yeah.
so it's even more basic. Like, so this actually strengthens your argument. The part in which I found very interesting was bringing coherentism to the picture, because I completely agree that
with yourself.
there's of course. I mean, I know that it's true, but the argument that I like X, therefore X, I've been told it doesn't work that well, at least with referees with me. But hey, no, but here's so I think it's crucial. I think you're really doing a nice work in distinguishing between relations and, let's say, extrinsic relational properties. Now, as a matter of fact, this was so. For example, if you go to structuralists, right, they seem to ignore that this. It seems to me that they seem to ignore that was the point. For example, in Black's original dialogue, that's very clear, right? These are very distinct metaphysical things, and you can do without not relations. You can do with extrinsic relational properties. Now, but here's what I don't get now. Like, so it's just a clarification question. Walk me through it. So here's a claim that Carlo, I think, should make, right? System S1 has spin X up relative to, let's say, relative to system 2, right? This might be constructed as an extrinsic relational monadic property of S1, let's say. It can even be constructed also as a relation. I don't care now. And this underwrites, let's say, a sort of dependence claim of S1 on S2. S1 depends for its qualitative profile on S2. So you cannot really, but now where's the symmetry here? Where does S2 depends on its qualitative profile on S1? Just in a simple, not in an entanglement case, just in a simple superposition case, let's say. I mean, I know that this is common entanglement, but it's the second part that I don't see. I see that I have spin up relative to Carlo, let's say, spin X up relative to Carlo, and therefore I depend on Carlo, right, for my qualitative profile. Now, but the coherentism requires that. Now Carlo depends on me for the same respect. So, and that as of now, I just can't see it.
Okay, shall I go, Mauro?
Well, as to the first point, I think we agree here, because Carlo is a little bit uncertain whether to say that it doesn't even make sense to attribute to the universe as any state, so that it's meaningless. That's what he says in the quotation that I gave. I think if I were to press him now, he would say it's indefinite. So there is no definite state of the universe unless we correlate with the universe. So if you want, by referring to your latest paper on this, Claudio, we should say indeterminateness, something that doesn't possess any property, which I think shouldn't be equated with having no property whatsoever. And maybe Matteo now should have his place here.
So, Claudio, your basic point is that, if I understand you correctly, that coherentism requires symmetric dependence. And I don't really agree with this, in spite of the fact that we worked on this together. So let me put it simply. Foundationalism is the claim that necessarily dependence is asymmetric. Coherentism is the negation of this. So you don't get a necessity claim, you get a possibility claim. So it is possible to have symmetric dependence. So now it's about the physics. Does the physical theory tell us that whenever you have interaction, you have one system affecting the other and the other way around? The answer might be yes or no, but the coherentism should be happy either way. Because if it's a yes, then you always get symmetric dependence. If it's a no, you get it sometimes, which is fine.
No, perfect. Okay. So that was actually what I wanted to ask. In these cases, right, of course, you don't need in every case symmetric dependence. Yeah. So in this case, though, you would say that in this particular, so in the entanglement case, it can be symmetric, but in this case, Carlo should say, like, I depend on you, for example, for my, let's say, qualitative profile, but you don't always get the, the comment, I mean, the other direction. So if that's what you guys are suggesting, then I'm completely fine with that.
I don't know, I'm curious to hear from Carlo. I mean, it seems to me that whenever you have a physical interaction, it's two-way interaction, but I might be wrong. Maybe. I mean, how can I measure something without being affected by it? In the terms of relational quantum mechanics. But I might be completely wrong again.
We can keep this for the discussion. I think yeah. Carlo is taking notes.
Looks dangerous.
So okay, I'm very sorry, guys. I have to apologize. You couldn't expect anything different from a conference organized by 3 Italians, but we are 6 minutes late. And so I suggest we still take a 4 minutes break and we start 10 minutes. So we start a bit late. So we reconvene in 4 minutes. And sorry everyone for the delay. And thank you again, Matteo and Mauro, of course.